All right, we're going to talk about the definition of acids and bases. And we have a couple different definitions. It doesn't really matter that we know the names of the definitions. The first definition I'm going to give you for an acid is what's called the Arrhenius definition. And that is that acids yield H plus in solution. Okay, so let's look at an example of H plus being formed in solution. This is something you're relatively familiar with, I would imagine. So if we have something like HCl, and it is aqueous, we talked about this the other day actually, on Monday, it will yield, when it ionizes, H plus aqueous and Cl minus aqueous. Okay, pretty straightforward. And we can also have what we call the Bronsted-Lowry definition. And that is that acids donate a proton. Okay, so acids donate a proton. And what that means is if we have HCl, aqueous, plus something like water, when they react, we get this H3O plus aqueous plus Cl minus aqueous. Now you might look at this and recognize that it's pretty similar to the reaction above. It's just we've added a water molecule to both sides. Because this H3O plus is really just H plus aqueous plus a water molecule. And that gives us H3O plus aqueous. So that's where that comes from. And this is what we call the hydronium ion. Now, the hydronium ion is a bit complicated. It's technically correct in that there is no such thing as H plus in solution. However, H3O plus doesn't actually exist either. What actually exists in solution is something like, I think it's H13O6. So it's 6 water molecules surrounding an H plus. Okay? And an H plus, the reason that happens is because H plus has a very high density of charge for its size because, I forgot to mention, it's just a proton. What do I mean by just a proton? Well, if we have a hydrogen atom, it has a proton, and then around it there's an electron. Right? That's our atom. Well, if it's H plus, that means we get rid of the electron. So all we have left is just the proton. So when I say that hydrogen donates a proton, what I'm referring to is the fact that it is donating an H plus. H plus and proton are the same thing. And also, hopefully not to confuse you, I use H plus and H3O plus interchangeably. Interchangeable. So when you get to Chem 112, that will not be true. But in this class, I try to keep it simple and use only H plus because, like I said, I'll just try to keep it simple. Okay, so that's an acid. Let's talk about bases. So there's two definitions for bases as well. So the first definition is that bases yield OH minus in solution. So this is fairly straightforward. Again, if we take something like Na, every once in a while my pen doesn't want to work, sorry, NaOH, and it's aqueous, it dissociates, because this is just a simple ionic compound, into sodium ions and hydroxide ions. No big deal there, okay? Very simple. Slightly more complicated definition of hydroxide is that it accepts a proton. Okay? So an acid is a proton donor, therefore we need something to accept that proton. So that is our base. Let's look at an equation showing that. So if we have something like acetic acid, CH3COOH, aqueous, of course this is a weak acid, we'll talk about weak versus strong acids in the next video, or in one of the videos anyway. And we have a weak base, like NH3 aqueous. We have an equilibrium. The forward and backward arrows just mean equilibrium. Don't worry too much about that right now. Again, that's more for Chem 112. We get CH3COO minus aqueous plus NH4 plus aqueous, which is ammonium. And so what actually happened here was that, let's use the highlighter. This hydrogen, I'll use my finger then. That hydrogen was donated to the NH3. And when the hydrogen gets donated to the NH3 accepts it and becomes NH4 plus. So that's it for this video.